Hello, today we're going to be going through LeetCode problem 53, which is the maximum subarray. Let's take a look. Given an integer array nums, find the contiguous subarray containing at least one number which has the largest sum and return its sum. Subarray is a contiguous part of an array. So if you look at the first example here, it's saying 4, -1, 2, and 1. If you add all those four numbers together, has the largest sum of 6. In example 2, we only have one number, so that will be the largest sum. I think example 3 is a pretty good example here so if you have 5 plus 4 is 9, then you subtract, you have to go in order, you can't like skip numbers. So 5 plus 4 is 9, minus 1 is 8, and then you add the 7 and 8. So the whole thing is actually the subarray, the largest number that you can have. So the output is 23. All right, so let's take a look at how we're going to tackle this. All right, let's say I start with -2, 1, -3, and 4. So we're going to start with the first number, and we're going to define two variables. So we're going to have an integer current array and an integer max array. So we're going to add the second number to -2 to get -1. And now we need to compare this second number, which is just the 1, and take the greater of the two. So the greater of 1 and -1 is obviously 1. And so now that will be our current array, our current greatest array. And so we need to compare the current array 1 with the max array, which we defaulted to -2, and take the greater. So the current max array is just the number 1. And rinse and repeat. Next time through, we take -3 and add it to the current array to get -2. So we're always adding the current number to the current array to see if it's going to be greater than just the number itself. We compare the result, -2 to -3, and we take the greater. So now the current array value is actually -2. But when we compare that to the max array, it's not going to hold up, and so the max array is still going to be 1. So finally we take 4, add that to the current array of -2 to get 2, and compare it with 4 and take the greater. And finally we compare this current array with the max array and take the greater, and return the max array. So in this case, 4 is the maximum number that you can get. And if you look at it, this kind of makes sense because you have -2, -3, so you already have -5 here, and then you're just adding 1. But there's no way two negative numbers is going to be greater than just the number itself. So, all right, so if we pseudocode this real quick, we have an array called nums. So like I said, we're going to define an integer current subarray and assign it to the first number in the array. We're going to define a max subarray and assign it to the first number in the array. We're going to loop through each number. We're going to set the current subarray to the max of the current number, or current subarray plus the current number. And then we set the max subarray to the max of max subarray or current subarray. And then we end the loop and return max subarray. So pretty straightforward once you figure out the algorithm to do this. So let's code it. So we're going to define int current subarray is num0 and int max subarray is num0. So if we kind of use the example -2, 1, -3, and 4 that I was using before, so both of these would be -2. And we're going to loop through all the integers and nums, and we're going to start with 1 because we already have the first number here, so there's no need to compare it to itself. So current subarray is, so math.max is how we're going to take the greater of the two numbers. So we have num sub I, which in our case would be the 1, or current subarray, which is -2 plus 1. And then we're going to take the current subarray and the max subarray and do math max on those two and get the greater of the two. And that is pretty much it, and return the max subarray. All right, so let's take a look at this in IntelliJ. All right, so I have the method here, and I use the same values that we'd had before, -2, 1, -3, and 4. So if we go through current subarray, max subarray, both -2. We're going to loop through here. So current subarray, math max of 1 or -2 plus 1. Obviously, current subarray is going to be 1, and then it's also going to, max subarray will also be 1. We'll go through again. Current subarray becomes -2 because we have -3 here, and then current subarray, which is -2 plus the nums or whatever. So the greater of the two of those is the greater of current subarray and max subarray is still 1 because current subarray is -2. All right, so the very last time we go through, we're comparing 4 to 4 plus -2. So obviously 4 is going to be greater than 2. And now we have the max subarray, which is just the 4. And we're going to return that. And there you have it. So last thing I'll do is go through the space and time complexity. So time complexity is O of n. We have to iterate through all the characters, or all the integers actually, in nums. And because if you increase nums, you have to, there's more stuff we have to iterate through. So it's linear complexity, O of n. The space complexity measures the total amount of memory, and this is O of 1. So basically, current subarray and max subarray are never going to increase. Like when we have the current size, it's never going to increase. Nothing in the problem increases the size of these, so it's just constant complexity. And actually, I forgot to do the LeetCode submission. My apologies. So let's run that. That is accepted, and we'll submit it. So pretty fast, faster than 96.28% of the submissions, and we use we're probably less than 42%, so a little bit greater than middle of the road. But we'll take it. Anyway, that is all I have. So again, good luck on your interviews, and let me know if you have questions. Thanks.